Geometry kids, it's Massey. So this is lesson 8-1 on the Pythagorean theorem and its converse. And this is your warm-up. The squares below fit into groups of three to satisfy the following equation. Area of square 1 plus area of square 2 equals the area of square 3. Now you can see that each side length here is 4, okay, or 2, or 6, or 10, etc. Okay, so you need to calculate the area by squaring it. Using each square only once, write an equation for each group. What is the relationship between the three sets of numbers? Explain. So you're going to try and sort these into groups of three, where the area of square 1 added to the area of square 2 will equal the area of square 3. This is a warm-up, so you're going to pause this now and you're going to try and do this. Find two squares that when you square their side lengths and you add them together, you get the square of the other side length of a different square. Okay, pause it, try it now, and when you start the video back up, we will talk about the solution. Okay, so how do we want to approach this? Well, let's find the area of each square. Let's write in what the area of each square is, and then we can maybe more easily see what the relationship is. I'm going to stop here and fill those in. You should do the same if you haven't already calculated the area of each one of these squares. All right, so here's all the areas written in, and what we need to do now is then find two areas that will add together to equal a third area. And if we look around for these, I can see that 36 here, 6 squared, plus 64, 8 squared, will equal 10 squared, which is 100. Okay, and I can write that, just say this plus this equals this. Okay, or 6 squared plus 8 squared equals 10 squared. Okay, what else do we got? Let's see what's left. We have, I can see that 9 plus 16 equals 25. Which is essentially 3 squared plus 4 squared equals 5 squared. And finally, what do we have left? Well, we've got 1.5 squared, 2.25, plus 2 squared, which is 4. 2.25 plus 4 is 6.25, which is this squared. So this plus this equals this, or 1.5 squared plus 2 squared equals 2.5 squared. Okay? And the question then becomes, what's the relationship between these sets of numbers? Check it out. If you took 3 and took half of that, you'd get 1.5. If you took 4 and took half of that, you'd get 2. If you took 5 and took half of that, you'd get 2.5. By scaling them, the 3, the 4, and the 5 down by a factor of 2, dividing them all three of them by 2, you get 1.5, 2, and 2.5, and these two smaller ones square and add together to equal the square of the larger one. You could also scale it up by a factor of 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, and those, when you square them, also these smaller ones squared and added together equal the larger. So there is this relationship between what we call here a Pythagorean triple, and this is going to be what you're going to learn in today's lesson, which is there are sets of numbers like 3, 4, 5 that are special Pythagorean triples. In this case, they're whole number values that when you square two of the values and add them together, you get the square of the third. And you can scale them up or down and still get values that when you square the small ones and add them together, you get the square of the larger one. Let's see what this looks like in the video. Hope this makes sense to you so far. This is the basis of today's lesson. Okay. The equations in the solve it demonstrate an important relationship in right triangles called the Pythagorean theorem. And the theorem's named for Pythagoras. He's a Greek mathematician, lived in 500s BC, about 2,500 years ago. And we've since discovered by being able to translate texts that the Babylonians, Egyptians, and Chinese were aware of this before Pythagoras discovered it. And there are many ways to prove that this is true. And there's one in this lesson and others later in the book. I'm going to show you a visual demonstration of the Pythagorean theorem right now. Okay, best I can tell, this is a kid's science demonstration, but here you go. You can see that the two sides of this triangle, when you square the lengths of the sides, and you take the areas and you combine them, you get exactly the square of the hypotenuse. Okay? This side squared plus this side squared equals this side squared. Exactly. Pretty fascinating. The Pythagorean theorem will come up in lots of your standardized testing. It will come up in lots of situations where you need to calculate and solve mathematical problems. So you're best to learn it. Now, as it says in the essential understanding, if you know the lengths of any two sides of a right triangle, you can find the length of the third side. You have this formula here, a squared plus b squared equals c squared, where a and b are the two legs the two sides that make up the right angle. Okay, the hypotenuse is always diagonal across from the right angle, and it is the one side that is not making the right angle. These two sides make up that right angle. Okay, so the theorem states if a triangle is a right triangle, then the sum of the squares of the legs, the lengths of the legs, equals the square of the length of the hypotenuse. Take this measure and square it, plus this measure and square it, and it will equal this length squared. And if you're missing one of these values, you can plug in the two that you know, and you just need to be sure that you're always plugging in this hypotenuse value here on this side. Okay? And then you can calculate out the missing side if you are missing any one of the values. Okay, so as I mentioned, a Pythagorean triple is a set of non-zero whole numbers. Whole numbers meaning positive values. Why are they positive values? Because they're representing lengths. Non-zero whole numbers, A, B, and C. Integers, whole numbers meaning not fractions or decimals, but integer values that satisfy the equation a squared plus b squared equals c squared. This is the Pythagorean theorem here. Below are some common Pythagorean triples. 3, 4, 5, that is the most common. 5, 12, 13, also very common, and you are going to see that come up a lot in your standardized tests. There's also 8, 15, 17, 7, 24, 25. You've got the 9, 40, 41. There's you can go on the internet actually and type in Pythagorean triples and you'll get the list of them. What they won't give you are the multiples. It says here, if you multiply each number in a Pythagorean triple by the same whole number, the three numbers that result also form a Pythagorean triple. For example, if you take the 3, 4, 5 and you multiply it by 2 or 3, you get 6, 8, 10 or 9, 12, 15 respectively. Those sets 6, 8, 10 and 9, 12, 15 each result from multiplying these 3, 4, 5s by a whole number, in this case times 2, and in this case times 3. Standard way of describing Pythagorean triples, if you're going to list them, is to list their simplified set. So this would be the set that you would name, not necessarily this, but you will see that come up a lot. And as we saw in the warm-up, you can multiply the numbers in a Pythagorean triple by anything, including 1/2, and you will get 1.5, 2 and 2.5 as we came up with in the warm-up, and find out that you get 2.25 plus 4 equals 6.25. No matter what you multiply them by, as long as you multiply all of these by the same value, you're still going to get a set of 3 numbers that works. Now, these aren't Pythagorean triples because they're not whole numbers, but just know that you can scale any Pythagorean triple up or down and still get a set of numbers that holds true when you square the 2 smaller ones and add them together. You'll get the square of the larger. These, in particular, these are worth memorizing and being able to recognize the multiples like 6, 8, 10, and 10, 24, 26, because it's going to come up a lot, as I said, in standardized testing. All right, so let's take a look at problem 1 in the examples. Finding the length of the hypotenuse. What is the length of the hypotenuse in triangle ABC? We have the 2 legs, 20 and 21. Do the side lengths form a Pythagorean triple? Essentially what we've got to answer is when we square these 2 leg lengths and add them together, do we get a number that is the perfect square of a whole number? So let's take a look. Okay, you're going to take the length of one leg and square it plus the length of the second leg and square it. Either leg, the legs are interchangeable, so there's neither one of them is the preferred leg 1 or leg 2. There's just one of them, the other one. Okay, so you don't need to say which one is leg 1 and which one is leg 2, or which one is A or B. Just A and B are the legs. So we square them, add them together, and we'll get the length of the hypotenuse. So that's what this is showing, the Pythagorean theorem. A squared plus B squared equals C squared. They're using 21 for A and 20 for B. So when we square those, 21 squared is 441, 20 squared is 400. And when you add them together, 841, you get C squared. What you need to do now is you need to square root this. Since you're allowed to use a calculator in geometry, you should know how to use your square root button, and you will square root 841, and what you get is 29 equals C. I think that they should have kept 29 on this side for consistency, moving it down the page, but either way, it's equal. C is equal to 29. When you take the square root of a number, remember, when it says here take the positive square root, what they're getting at is this, that negative 29 squared, negative 29 times negative 29, is the same as positive 29 times positive 29, okay? So when you square root 841, in this case, it could be equal to negative 29 or positive 29. Since we're talking about lengths, and lengths are always positive, we're going to take the positive square root, okay? Now, it's asking us a question, is this a Pythagorean triple? Well, did we get a whole number? We had whole numbers for the legs. Did we have a whole number for the length of the hypotenuse when we calculated it out? And as you can see here, we did get a whole number. So we have as an answer, the length of the hypotenuse is 29. So we have side lengths 20, 21, and 29. They form a Pythagorean triple because they are whole numbers that satisfy a squared plus b squared equals c squared. Hopefully that makes sense to you. Now, you're going to try this got it problem, and what you're going to do after I show it to you is you're going to pause the video and you're going to write down your answer. Make an honest attempt at this. This is how you're going to learn, especially with this online learning. If you're rushing through the video, if you're not honestly attempting the got it problems, your understanding and your learning is going to be lessened. And then you can't be surprised when you do poorly on the test, because that's where you have to show all of the work that you've been doing. There's not a ton of work you're submitting, so the work that you're doing, the effort that you're putting in, is only going to show up on your test. So pause the video now after reading this question. What does it say? It says the lengths of a right triangle are 10 and 24. What is the length of the hypotenuse? And then the question is, when you find that hypotenuse, do those lengths form a Pythagorean triple? Pause the video right now and see if you can answer this question, and then unpause it to see the solution. So what do we know? Well, we know that we have leg lengths of 10 and 24, so we need to be taking 10 squared plus 24 squared, and that will equal the hypotenuse length, which we're calling c squared. Calculating that out, you get 100 plus 24 squared is, gosh, what is 24 squared? My best answer for this is to calculate it. I don't have a calculator. And we get 576. Okay, so 576 equals c squared. And when we add those together, we get 676 equals c squared. So then the question is, if the square root of 676 equals c, what do we get here? And as it turns out, if you type this into your calculator and you square rooted it, you would get 26. And is that a Pythagorean triple? Well, is it 3 whole numbers? It sure is. So we've got a 10, 24, 26 Pythagorean triple. And hey, fun fact, this is just the doubling of Pythagorean triple that we already learned, which is the 5, 12, 13. Okay, so what's the length of the hypotenuse? For answer A, the length of the hypotenuse is 26. And does it do the side lengths form a Pythagorean triple? Yes, they do, because they are 3 whole numbers that that satisfy the Pythagorean theorem: a squared plus b squared equals c squared. Let's look at another example problem. All right, so in this example problem, what we're doing is finding the value of one of the legs. What's the value of x? Express your answer in simplest radical form. This means that we're not going to be getting a perfect whole number and not necessarily dealing with Pythagorean triple, because we don't have to always deal with a perfect Pythagorean triple. Giving you an example of 3 lengths that they could be, you could have, let's say, 2 squared, plus 3 squared, and that equals, let's say, c squared. So now you get 4 plus 9 equals c squared, or 13 is equal to c squared. Well, what number, when you multiply it by itself, equals 13? Well, the square root of 13. That's not a perfect whole number, okay? But it certainly is true. So you could have a length, a hypotenuse length that is square root of 13, which is somewhere between square root of 9 and square root of 16, or somewhere between 3 and 4, okay? So you could have numbers that are not all Pythagorean, not all whole numbers, and therefore not Pythagorean triples. That's certainly possible. So then the question becomes, what is the value of x for the problem that they gave us? So let's take a look at their solution. Use the Pythagorean theorem. Now notice this, we've got one of the legs, and one of the legs is a variable that we're missing, and we have the hypotenuse. So we're going to substitute in one of the legs with 8 and the hypotenuse with 20 and square those values. Okay, so 8 squared is 64, 20 squared is 400, and now to solve this thing, the first thing you're going to need to do is subtract 64 from both sides to be left with x squared. Okay, and then you get 336. If you were to square root that, you would get x is equal to the square root of 336. And what do we need to do here? Well, I'm going to show you. They're saying factor out a perfect square, which is 16, because you can perfectly square root 16. That comes out as a 4, and you get 4 root 21. Now, how do you know how to do that on your own? Well, here's what you should do. You can take 336, and you can do a factor tree on it. Okay? You can divide it by 2. You can say that's 2 times what's half of it? 336 divided by 2. You can do that on your calculator. 2 goes into 13 6 times. Sorry. which is 12. Bring down the 6. 2 goes into 16 8 times, and you get 168. This is a prime number. This is not. If we were to divide it, it's an even number, so we could divide it by 2 again. We can get 2 times 84. I can do that one in my head because I can take half of 16 is 8 and half of 8 is 4. And then we can keep going. We can say 84 is just 2 times 42. 42 is 6 times 7. 7 is prime. And 6 breaks down into 2 times 3. Both prime. So if we were to write that out, that would be the square root of 336 is the same as the square root of 2 times 2 times 2 times 2 times 3 times 7. And anytime you see, and when you break it down into prime factors like this, anytime you see it in there twice, 2 times 2 is 4. What's the square root of 4? A 2. So you can bring it 2 out. There's another 2 times 2 or 4. What's the square root of that? 2. Bring that out. 3 and 7 don't have matches, so they stay inside as 3 times 7. And when you were to then multiply them back together, 2 times 2 is 4. Root 3 times 7 is 21. And as you can see, you still get what they got. Okay? So if you don't know how to do simplest radical form, well, the way that you do it is you take the number that you're taking the square root of, in this case 336, and you can do a factor tree and break it down into its prime numbers that make it. And anytime you find a pair in there, you bring that number out once. So we brought 2 2's out. They multiply together to be a 4. Whatever's left, the 3 and the 7, multiply back together to be the 21. Okay? Got it? Well, not sure if you got it, so I'm going to erase these marks real quick, and we can take a look at the got it problem right now. Here it is. The hypotenuse of a right triangle has length of 12. One leg is length 6. What is the length of the other leg? Express your answer in simplest radical form. What you should do now is you should pause the video. You should make an attempt to try and find out what do you think that length of the leg is in simplest radical form, and then you'll unpause it and look at our answer. Okay, so we know that the hypotenuse is 12. That's going to be C. So one leg is 6, so we've got 6 squared plus B squared equals C squared, which is 12 squared, or 36 plus B squared equals 144. And when we subtract 36 from both sides, we get B squared is equal to 108, and therefore B is equal to the square root of 108, and we will need to figure that out by doing a factor tree on 108. I know that that's 2 times 54. 54 is 6 times 9. 6 is 2 times 3, each prime, and 9 is 3 times 3, also prime. So then we can say B is equal to, instead of writing the square root of 108, we can say the square root of 2 times 2 times 3 times 3 times 3, because those are all of the prime factors that we got. Now, if you can find a pair, we can bring it out. We've got a pair of 2's. So that we can bring that out and say B equals, and that pair of 2's we can bring out as a single 2. What else do we find? We find a pair of 3's, so we can bring that out as a single 3. And what's left? Well, this last 3 does not have a pair, so it stays in as what it is, like that. what was brought outside? 2 and the 3. We multiply together to be the 6. So we've got b is equal to 6 square root of 3. And that is the length of the other leg in simplest radical form. Okay, problem 3 is a word problem. Dog agility courses often contain a seesaw obstacle, the seesaw here. And to the nearest inch, how far above the ground are the dog's paws when the seesaw is parallel to the ground? When the seesaw is parallel to the ground, then the dog's paws are going to be whatever this length is here. Okay? So what you're calculating is one of the legs. Let's see how they solve this. They say, write the Pythagorean theorem, a squared plus b squared equals c squared. And now fill in what you know. You know that one of the legs is 26 and the hypotenuse is 36. So you fill those in and you leave b missing because we don't know what it is. Okay? Calculating 26 squared is 676, 36 squared is 1296. And then you're going to subtract that 676 from both sides and you'll find that b squared equals 620. Now, notice how it says to the nearest inch up here. If it says to the nearest inch, that means that you're going to actually calculate it and you're going to round it to the nearest inch. So you're going to use the square root button on your calculator, square root 620, and you get 24.8997992 approximately, which rounds to the nearest inch to 25. So to the nearest inch, the dog's paws are 25 inches above the ground. Okay? And here's your got it problem. The size of a computer monitor is the length of its diagonal. You want to buy a 19-inch monitor. If you were to sketch this out, let's say you've got a monitor like this. Oops. Okay. And since it's a 19-inch monitor, you know this length right here is going to be 19 inches. And you want to buy a monitor that has a height of 11 inches. This is 11 inches. Okay. What is the width of the monitor? So you've essentially got a triangle here, this triangle right here, where you're finding one of the legs. Okay. Round to the nearest tenth of an inch. Calculate that right now. Pause your video and calculate that right now. Okay, so let me move this out of the way. See if I can grab it. I'm going to put it up here. What you've got then is 11 squared plus b squared equals 19 squared. And when you subtract 11 squared from both sides, you get b squared is equal to 19 squared plus 11 squared. And if we calculate that here, we get, let's see, 19 squared is 361. Oh, I'm sorry. I said plus, it should have been minus. Right there, my mistake. Hopefully you caught that. Subtracting it, okay? Minus 11 squared is 121. And if we subtract 361 minus 121, we get b squared equals 240. And therefore, b is approximately equal to, if we use the square root button and round it to the nearest tenth, we get 15.49, which rounds to 15.5. So round to the, what is the width of the monitor? The width is 15.5 inches when rounded to the nearest tenth of an inch. Okay, so you notice that the name of this lesson was the Pythagorean theorem and its converse. You can use the converse of the Pythagorean theorem to determine whether a triangle is a right triangle, because the Pythagorean theorem only works when the triangle is a right triangle. So, as the theorem states, if the sum of the squares of the lengths of the two sides of the triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So if you take these two sides and square them, and you get the square of this, then you know you're dealing with a right triangle. Let's look at that in action. Okay, so problem 4, they give us triangle side lengths. The triangle has side lengths of 85, 84, and 13. Is the triangle a right triangle? Obviously, the hypotenuse is the longest, so this is the one that you're going to have to use as the hypotenuse. So is 13 squared plus 84 squared equal to 85 squared? Let's see. You see a question mark over that. They're saying, is that equal? Okay. And when you plug the numbers in and you calculate it all out, you find that indeed you get the two shorter lengths when squared equal the longer, and squared and added together equal the longer length squared. So yes, the triangle is a right triangle because 13 squared plus 84 squared equals 85 squared. It's a Pythagorean triple. Okay? Here's your got it problem. You should pause the video after seeing it and then come back and check your answer against ours. Okay, here's the question. Triangle has side lengths of 16, 48, and 50. Is the triangle a right triangle? Explain. Also, once you know that which length represents the hypotenuse, it's of course going to be the longest one. Does it matter which ones you use for A, which you substitute for A, and which for B? Explain. So pause the video now, try and answer both of these questions, come back and check your answer. Okay, so what we need to do here is we need to check, is 16 squared plus 48 squared equal to 50 squared? Okay, 16 squared is 256. 48 squared, 48 times 48 is 2,304. And 50 squared, I actually don't need to check, I can do that in my head, is 2,500. And if you add these together, you get 2,560 is not equal to 2,500. Nope. So is the triangle a right triangle? No, because squaring the two shorter sides and adding them together does not equal the square of the longer side. Okay. Part B says, once you know which length represents the hypotenuse, does it matter which length you substitute for A and which length you substitute for B? Explain. No, it does not. As long as you're using the longest as the hypotenuse, you can see that switching these values around and putting 48 here and 16 here would still result in 2,560. So it doesn't matter where you put the legs, it just matters that you use the longest side as the hypotenuse. Okay, you can determine whether a triangle is obtuse or acute by testing the lengths out and seeing whether, if they're not equal, which one is bigger. Is the hypotenuse bigger, or is the two sides squared and added together bigger? Okay. It's related to the hinge theorem, which states that the longer side is opposite the larger angle and the shorter side is opposite the smaller angle. So here's what it says. If the square of the length of the longest side, that's that longest side, is greater than the sum of the squares of the other two sides, then you can see that this side had to extend longer and make this angle greater than 90. Therefore, the triangle's obtuse. Okay? If the square of the length of the longest side, which they're going to give you numbers, ends up being less than, that's c squared, this is less than the sum of the squares of the lengths of the other two sides, this squared plus this squared. Okay? If that side is smaller, then that means that you needed to shorten that side less than what it would be when it was perfectly a right angle, and therefore this angle has to close less than 90 degrees, therefore the triangle is acute. Okay, Okay, so we're going to classify it as acute, obtuse, or right, and we're using the Pythagorean theorem to do so. So a triangle has side lengths of 6, 11, and 14. Is it acute, obtuse, or right? Well, let's take that longest side and square it, and take these shorter sides and square them and add them together. This squared plus this squared should equal this squared if it's right, and if this ends up being bigger, it's obtuse, and if this ends up being less, then it's acute. So what does it look like? We're going to actually set it up like this. Say, is it greater than, less than, or equal to? And you notice this is a little bit, the typing was wrong in the book, but it says you're going to compare c squared to a squared plus b squared. Okay? So you're going to fill in those numbers. You're going to say 14 is the longest side, so that's going to go where the hypotenuse is. How is 14 squared compared to 6 squared plus 11 squared? And you always substitute the greatest value for c is what that says. And when you do that, you plug those in. When you add them together, you say, oh, look, the hypotenuse, or that longest side is longer than the other two sides squared and added together. So since c squared is greater than a squared plus b squared, the triangle is obtuse. Here's your got it problem. The very last one is a triangle with side lengths 7, 8, and 9, acute, obtuse, or right. You're going to pause this, you're going to attempt it, and then you're going to see what my answer is and if it matches with yours. Okay, so what we're going to do is we're going to do the same thing that they did above, which is how does c squared compare to a squared plus b squared? Okay, and since the longest side is 9, we're going to say 9 squared. How does that compare to 7 squared plus 8 squared? Okay, 81. How does that compare to 49 plus 64? Well, 81 is less than the sum of these two, which is 113. And since that longest side is less than, that means that essentially what you have is, if you had it as exactly a right angle, this would be a certain length. And since that is actually less, what you've got to do is you've got to close this angle down shorter than 90 in order to shorten this side and make it shorter. Okay? That means that you've now gone less than 90 degrees for the angle, and you have an acute angle. That's it. This is the lesson. I know it's kind of long. I'll try and keep it short as possible, but since we're just starting this unit, it's worth a thorough description of this. So good luck. Log into class and ask questions after you've done the IXLs on the lesson pages and after you've practiced by doing the homework problems and watching the solution videos. Good luck.